What if I told you that every time you board a plane, you're technically time traveling, aging microseconds slower than people on the ground, and the proof is sitting in satellites orbiting above your head right now? Hit that like if you're ready to crack open the universe's deepest cheat code, because we're about to dive into the wild, verified science of bending time itself. Right now, this second, astronauts on the International Space Station are moving through time differently than you. Time dilation isn't science fiction, it's science fact, proven every single day by GPS satellites that have to account for Einstein's predictions, or your navigation would drift miles off course in hours. But here's where it gets absolutely mind-bending. If astronauts can travel to the future by fractions of seconds, could we push that effect to years, decades, or even rewind the clock entirely? Physicists in 2025 are saying maybe, and the breakthroughs happening right now are stranger than any movie script. Let's ground this in something visceral. Picture twin brothers, identical down to their DNA. One stays on Earth, the other rockets into space at 99% light speed for what feels like 1 year to him. When he returns, his Earthbound twin is now an old man, maybe in his 80s, while the space twin barely aged past his 30s. This isn't fantasy. It's Einstein's special relativity in action, confirmed by experiments with atomic clocks on jets in the 1970s. The faster you move, the slower your personal time ticks compared to someone standing still. It's called time dilation, and it's your cosmic loophole to the future. No wormhole required. Astronaut Scott Kelly spent 340 days on the space station and aged about 8 milliseconds less than if he'd stayed home. Tiny, yes, but it proves the principle. Speed stretches time, but traveling forward is just the warm-up act. The real headache, the holy grail that keeps physicists awake at night, is traveling backward. Can you rewind to stop your own birth, meet dinosaurs, or buy Bitcoin in 2010? The math says it's not impossible, but reality throws up roadblocks like a bouncer at the universe's most exclusive club. Enter wormholes, those theoretical tunnels through space-time that Einstein and Nathan Rosen cooked up in 1935. Imagine folding a piece of paper so two distant points touch, then punching a hole through both. That hole is a wormhole, a shortcut connecting not just far-off galaxies, but potentially different moments in time. Here's where it gets electric. Physicists from the University of Alberta and Charles University discovered a loophole in Einstein's equations in 2024 that could allow ring-shaped wormholes to create what's called closed timelike curves. That's physicists speak for a path through space-time that loops back to its own starting point, a literal time loop. One end of the wormhole accelerates near light speed, while the other stays put. And boom, time at the fast end slows down compared to the stationary end. Step through, and theoretically you could emerge in your own past. Researchers Valery Frolov and Andrei Zelnikov joked they found a way to send you back in time to avoid that speeding ticket. But the science underneath isn't a joke. It's published, peer-reviewed, and currently blowing minds across the physics community. The catch, and it's a brutal one, is keeping that wormhole open. Without something to prop it up, a wormhole collapses faster than you can blink, crushed by its own gravity. What you need is exotic matter, stuff with negative energy density that pushes outward instead of pulling inward like normal matter. Negative energy sounds like comic book nonsense until you learn about the Casimir effect, a quantum phenomenon where two metal plates placed insanely close together in a vacuum experience an attractive force because the quantum vacuum between them has less energy than the space outside. That's negative energy, verified in labs, but we're talking microscopic scales. Scaling that up to stabilize a human-sized wormhole would require energy outputs rivaling entire stars, and we're nowhere close to harnessing that. Yet, here's where 2025 gets wild. Researchers at Washington University in St. Louis published a breakthrough in Physical Review Letters demonstrating quantum sensors that use entanglement to effectively probe past events, what they're calling time-traveling detectors. The experiment doesn't send matter back, but it uses quantum mechanics to retrieve information about a system's history in ways that shouldn't be possible under classical physics. Separately, scientists at the Austrian Academy of Sciences and University of Vienna published experiments showing they can speed up, slow down, and reverse quantum states of photons passing through crystals using a device called a quantum switch. They're manipulating time on the smallest scales, and while a photon isn't a person, every giant leap starts with a subatomic step. Then there's the Google quantum computer experiment that sent shockwaves in late 2020 but continues to fuel debate into 2025. Maria Spyropoulou's team at Caltech used Google's Sycamore chip to simulate a holographic wormhole, sending information through it via quantum teleportation. Critics argue the model was too simple to represent a real wormhole, but supporters say it proves space-time might emerge from quantum information, a cornerstone of the holographic principle trying to unite quantum mechanics and gravity. Whether it's a true wormhole or a clever simulation, the fact that we can model these effects on a chip is staggering. We're building baby universes inside computers, and that's not hyperbole. That's where the frontier sits today. But let's confront the elephant in the room: paradoxes. The grandfather paradox haunts every time travel discussion. If you go back and prevent your grandparents from meeting, you're never born, so you never travel back. So they do meet, so you are born, so you do travel back. Rinse and repeat into logical oblivion. Physicists have proposed solutions. One is the Navikov self-consistency principle, which states the universe won't let you create a paradox. Try to kill your grandfather, and the gun jams, or you miss, or something stops you every time. Reality enforces its own timeline. Another solution comes from the many worlds interpretation of quantum mechanics. Every time you alter the past, you split into a parallel universe. You prevent your birth in that timeline, but in your original universe, you still exist. You don't erase yourself, you just strand yourself in a branch where you were never born. Mind-bending. Absolutely impossible. Scientists in 2025 say no, not definitively. Drop in the comments, if you could visit one moment in history without changing it, where would you go? Because here's the kicker. Even if backward time travel stays theoretical, the implications of what we're learning now are staggering. Understanding how time bends under extreme conditions teaches us about black holes, the birth of the universe, and the very fabric reality is stitched from. Some researchers believe mastering time manipulation could unlock technologies we can barely imagine. Quantum computers that process information backward through time to optimize solutions, or communication networks that send data before it's requested, because the request echoes backward from the future. One speculative but grounded scenario. Imagine scientists in 2040 create a microscopic wormhole stabilized by harnessing quantum vacuum energy on scales we perfected through decades of research. They send a single photon through and detect it arriving nanoseconds before it was sent. That photon carries a message, encoded information that traveled backward through time. It's not Doc Brown's DeLorean, but it's communication with the past. And that alone rewrites everything we know about cause and effect. Teams are already modeling these scenarios, running simulations on quantum computers to test what self-consistent timelines look like when information flows both directions through time. Here's the other edge of the sword. Stephen Hawking proposed the chronology protection conjecture, a hypothesis that the laws of physics might actively prevent time travel to the past to avoid paradoxes. Every time we get close to building a time machine, some quantum effect or energy requirement blows up the possibility. It's the universe's way of saying no, you can't rewrite history. Recent experiments with quantum time reversal haven't disproven this, but they've shown that on quantum scales, time isn't as rigid as we thought. Particles can influence outcomes retroactively in delayed choice experiments, behaving differently based on decisions made after they've already passed through a detector. Reality at the quantum level doesn't respect our linear cause-then-effect intuition. So where does this leave us? We're on the cusp. Practical, human scale. Time travel remains beyond our grasp, locked behind energy requirements and exotic matter we can't produce. But the foundation is being laid. Quantum experiments are chipping away at the impossible, proving that time is flexible, that information can dance between moments, and that the universe might have loopholes we're just learning to exploit. Private investment is flooding in, with venture capital firms pouring billions into quantum computing and theoretical physics startups betting on breakthroughs that could redefine reality itself. A report from 2025 shows funding for wormhole and quantum gravity research has tripled in 5 years, because if even 1% of this pays off, it's a civilizational shift. This changed how I see the world. Time isn't a river we're helplessly swept along. It's a landscape we're learning to navigate, one quantum leap at a time. The nervousness you feel imagining these possibilities, that's not fear, That's your brain catching a glimpse of a future where the impossible becomes routine. Smash subscribe for more dives into the cutting edge. Comment your wildest time travel theory below, and share this with your adventure squad, because the universe is calling, and who knows what answers you'll uncover next. The clock is ticking, or maybe it's looping, and either way, we're just getting started.